All right, friends, it's time to get started for another chat. So, today we will be talking about facility systems, which is chapter 7 of your textbook. And with this lecture, I would like to give you a brief overview of the different systems that are in a facility and help us to appreciate how those different systems interact. So, without further ado, we really should start out with the question of what is heating, ventilation, and air conditioning, or an HVAC system? Well, the textbook calls the HVAC system the soul of the building because it's responsible for the heating and cooling and ventilation of your facility. And the heating element, of course, is going to be the process by which air is brought in to the ventilation system and utilizing energy creates usable heat and controls that heat and then finally distributes that heat throughout the facility. So, of course, air can be heated through different methods, whether it's coal or oil or natural gas. And through this different process, these different processes, the air, which at one point is cold, is heated, and then that heated air goes throughout the facility and encounters air that at one point is colder, but through transference, that process then heats and warms the room. So this steam heating transference system is going to be used in a way that's similar to traditional hot water systems that we understand, but it's used to uh, warm up a facility through steam. That air is warmed by the steam that's produced uh, through the different pipes and different ventilation shafts. Cooling is going to be uh, done through vapor, and most cooling systems are going to use a vapor compression system. And the optimal um, temperature, as the textbook mentions, is between 68 and 72 degrees. That's recommended by the American College Sports Medicine of Sports Medicine. And of course, cold water is pumped into radiators, and the surrounding hot air is then chilled. However, a facility's HVAC system, whether it's heating or air conditioning or ventilation, is going to be compromised or impacted by heat load. And heat load is really how a facility's temperature is impacted by two factors. One is the amount of people who are in the facility and what they're doing, their activities. So if we've got a large amount of people in a facility in a closed space, they're going to be giving out heat. And of course, their activity also gives out heat depending how strenuous that is. And then finally, actually, the third aspect could be different appliances or heat producing um, aspects related to the facility, whether it's stoves or washers and dryers, etc. They could also help to impact the heat load. And then, depending on how high the heat load is, how many people are strenuously acting, that can influence how hard a heating or cooling system has to work. The heating and cooling system, of course, is integrally impacted by the ventilation system. And a ventilation system is a way by which you have those different connections, the vents and uh, the ducts. That all helps to produce better air quality through extracting older air and replacing it with newer air. So cycling in and cycling out. So because most of us spend our day to day indoors, the vast majority of our time is either spent inside at work or school or in our homes. That's elevates the importance of having clean air. So again, the American College of Sports Medicine recommends 8 to 12 air exchanges per hour in facilities such as a gymnasium. And that can be accomplished with several large ceiling exhaust fans. So the textbook gives the example of Wimbledon, which used a comprehensive HVAC system to bring in air that is fresh and also cool the facility through underground chillers to maintain that um, that comfortable temperature. So the HVAC system is very comprehensive, and an HVAC system really accounts for about 20 to 25% of a new facility's cost because of its importance. A properly ventilated facility can help with cutting down on sickness in the workplace, as well as can boost productivity by keeping the air temperature at an optimal range that most of the workforce will find pleasant. So that highlights the importance from a productivity standpoint and a profitability standpoint for your facility. Of course, as we uh, continue on through the digital age, we're also seeing how technology is able to influence HVAC systems. And we're talking about here computers and automation. The textbook talks about how applications can be used from smartphones to help with aiding the HVAC system, make it smarter, more effective, and then also elements like motion capture detectors or cameras or automatic sensors can all help with turning on the elements of the HVAC system in as a way that it can be more effective and save money. As technology continues to um, advance, we should see smarter HVAC systems. And it's important, of course, to have uh, an optimal HVAC system because, as we're going to talk about very shortly, air quality is also important from a facility standpoint from several aspects. But here's just an example of air ducts in a ventilation system. So you can see on the left, we've got the sock system where you've got cloth. You have in the middle right there an air handler unit that sends air through that cloth sock. And a rumbling noise is going to signal the rush of air through the sock to fill up and then dissipate the air through the facility. And on the right, we have more of a traditional aluminum duct system, and the aluminum duct system is going to be more expensive. So facility planners have options to uh, try to minimize costs through different materials in your air duct system. And of course, you need to think about the cost of maintaining and replacing your HVAC system because if an HVAC system is damaged or needs to be repaired or goes down, that could end up being significant costs for your facility. Air quality is very important. And as the textbook mentions, there's different meanings about air quality. Um, uh, People might think that has to do with the uh, air environment, which might be the temperature, humidity, or the ventilation rate. But those factors really aren't necessarily going to impact air quality. Um, the air quality externally cannot be maintained or managed the same way that we do it internally. External air quality is really important as well when we're talking about air quality, both internally and externally. And air quality externally can be influenced by a litany of different aspects, whether it's smells in the air or chemicals. Um, you've got these external components such as the climate, uh, water infiltration, and then other particles and dust and radiation that's in the atmosphere itself. So these aspects are going to be influencing the environment. You see, as an example, and the textbook mentions this, that the Olympics in 2008 in Beijing had poor external air quality, and you can see the picture on the lower left, that's a picture of the bird's nest, and that's someone wearing a mask. And you can see the air is pretty foggy. So that can really influence the external variables when we're talking about external air quality. And then when you're talking about building and HVAC related concerns, that can also be important. So we're talking about the design or operations of the materials that are being used. And then finally, the internal elements could be things such as the interior design of the facility. Again, what materials such as paint sealants or adhesives, etc. And then the furnishings, all of these aspects are going to influence interior air quality. And interior air quality really needs to be considered in every facility design because um, the facility is going to be held accountable from a potential legal or environmental standpoint as to be maintaining a baseline level of air quality. And if it's not adhering to that, then it could suffer potential penalties. So when AT&T Stadium or Jerry World opened in 2009, it needed to comply with internal air quality standards, and also from a business perspective, a facility owner and operator is not going to want to have fans, patrons getting sick from the quality of the air. So that's certainly important. In terms of energy systems, well, how much energy does each facility system use? And we're talking about heating and cooling and lighting. So about 40% of the energy in a typical building is consumed by your cooling system, your air conditioner unit. Then 33% is going to be consumed by the lighting, which we're going to talk about, and 12% is the heating. So from a facility manager perspective, it's important to understand different ways to cut down on the costs of heating and cooling in lights so that we can manage our facility in a optimal manner. So that could be using motion sensors to turn off lights when no one's there, shutting off lights completely in some areas of the facility in the evening if it's not being used, materials that are used for the construction of the facility to help with insulation or help with reflecting light, etc., helping not to heat or cool a part of the facility that's not currently in use. So these are just examples of ways to save money with your energy system. And of course, you can use technology really to help cut that down, since 72% of the time a building could be unoccupied, as the text says. So that's certainly important. Lighting systems. So the text talks about lighting, and what we're talking about here is really the different types of light that a facility encounters. So ambient light or atmosphere light refers to the actual sunlight, but then there's also um, different classes of lighting that's going to be used to illuminate a facility. So when we're talking about lumens, we're talking about the output produced by a lamp, and that's the measuring force. So 1 lumen could fall a distance of 1 foot, and that would be the standard candle for a lumen. And light intensity is called a 1 foot candle, as the textbook talks about. So there's these different classes of light. Excuse me. Class 1 lighting is used in facilities that host competitive play. And that's going to be competitive play in front of a significant amount of competitors, or I'm sorry, a specific amount of spectators. And for that, for class 1, we're talking about lighting for 100-foot or 150-foot candles in the infield and 100-foot candles in the outfield. Now, class 2 is going to be facilities that are holding up to 5,000 people who are there as spectators, and that's going to be 100-foot candles infield and 70-foot candles outfield. And then finally, all other lighting that's the lowest level is a class 3, and that would be for small crowds or recreational facilities, and that's going to be 50-foot candles in the infield and 30-foot candles in the outfield. So that's how you would distinguish between the different classes of lighting. Indoor lighting is going to be distinguished and divided into different types of lighting. So direct lighting is going to be light that is directed downward from a fixture. So you see on the upper right hand side of the PowerPoint, you see the lights in the gym where you see the direct lighting that's lighting the floor, but then you also see ambient lighting that's going to be part of the windows where um, that are also letting in light. Indirect lighting is going to be from ceiling fixtures that focus the light against the ceiling going up, and then that 90% of the light energy goes back down to the floor from the ceiling. Anything less than that, 40%, 60% of the light reflecting back from the ceiling to the ground is diffuse lighting, and that is going to be that's going to be that's not going to be very much. Semi-direct lighting is going to bounce back only 10 to 40% of the light from the ceiling, so that's even less. So these are your different types of internal lighting. And the key to any sort of indoor lighting system is to make sure that the light is properly directed at where you actually want to be lit up. So it seems pretty straightforward, but that's really what we're after. And there's different types of lighting. There's, of course, the traditional filament lighting that's not very effective. In fact, it's going to end up costing a lot of money because of the ineffectiveness of the filament, and it's going to also result in lights being needed to be replaced quite often. And you need to, if it's a facility like the gym where you have to rent a some sort of apparatus to go up and manually change those lights. But other new technologies such as fluorescent lights or LEDs, this technology is going to be both more effective in terms of not using as much power, kilowatt hours, and then also it's going to have a longer life. So we're seeing facilities move towards that trend. So in the textbook mentions in Syracuse where they changed a facility from traditional lights to LED display lights specifically intended for sport facilities. And that facility saw power usage drop by 87% because of the more effective technology. Now, in order to appropriately suspend light, indoor lighting, a facility needs to properly install their rigging. So rigging is any sort of items that are suspended from the roof. And the key variable when we're talking about rigging is the load capacity, which is how much weight the system can support. So we need to make sure that the system is able to support what it's seeking to hang. So things like weight limits and forces and geometry, these are all important for facility managers to understand. Rigging strength can also be depleted or reduced by wear and tear and heat and then chemical exposure. So properly monitoring the rigging load is also important when we're talking about fighting reductions in load capacity. The textbook also talks about external lighting, the lights on the outside. So it could be the other two pictures on the lower right-hand side of the PowerPoint. External lighting, really what we're talking about here is quantity and quality. And the factors of external lighting really relate to the uniformity of the light on the field. How even is the light being cast onto the field? Unevenness is going to interfere with the potential quality of play, but certainly viewers who are viewing the play from the stands or other places. So the facility is going to want to guard against glare, which is where the light is reflecting or hard on the viewer's eyes. Also, problems can arise when too much light or uneven light is on the field, and that is sort of a symptom of trespass where light was intended to go into one area, but then it actually goes into another area. And then finally, sky glow is where the light is directed or reflected upward and into space, and it's wasted light. So these are different considerations that a facility manager needs to think about when talking about light systems and effectively minimizing glare, trespass, and sky glow can help with not only fixing um, the viewing experience but saving money. So that's certainly important. Finally, energy use is certainly important because of the cost savings. Energy programs can be established by facility in a way to audit the usage of that electricity, but certainly it's important to have a specific goal. So if there's a specific goal of how much energy the facility wants to save from lighting, that would be the first step. And then trying to monitor usage and engage in strategies intended to lessen use is a great way to help to minimize the cost. The textbook also talks about plumbing. In a typical office building, restrooms can account for about 37% of water usage. And when we're talking about water systems, it's not only restrooms, but it's basic plumbing, faucets, toilets, sprinklers, showers, and water fountains. Certainly, the restroom is more than 1/3, but also landscaping and cooling and heating are significant, and then kitchen and dishwashing uses are also important. So, from a plumbing perspective, it's important to understand your plumbing um, your plumbing system because it's very intricate and the water pressure in the plumbing system is highly technical. Now, the textbook talks about different wastewater systems, so recycling using gray water. That's a byproduct of um, bathroom usage or washing machines. And certainly that is a way to save money by reusing water if there's a treatment system within your facility. So that's something that facility managers should think about in terms of recovering the money that would be invested in a water treatment facility by saving that water, recycling that water. Certainly, water or fire suppression systems are also important because of the savings in costs by putting out a fire before it can really get started, and of course, preventing a loss of human life. Facility owners and managers are under a duty of care to protect a person who pays for the right to be on that facility from foreseeable risks of harm, and certainly it's arguably foreseeable that facilities would be subject or susceptible to a fire hazard, and a reasonably prudent facility manager or owner would have a fire prevention system in place. So, fire prevention really focuses on different questions about whether or not a facility complies with all appropriate codes and industry standards, whether or not they have a fire suppression and alert system available, and if so, whether or not that's adequate, whether or not potential hazards that would not be usually put out by water are taken care of by other means, whether it's um, chemicals or powders that could be used to put out fires, sensitive information like computers, and then whether or not there are escape routes and exits available and outlined, and whether or not there's the employees are trained in terms of how to respond to fires. And then finally, making sure that the fire suppression system is tested, that the fire suppression and response plan is tested, and that the employees understand that approach, and whether or not the facility has fire and carbon monoxide alarms throughout the facility, and whether or not those are being tested to make sure that they're not running out. So risk management is certainly an important aspect of fire suppression systems and making sure that the facility is adequately protected and adhering to their duty of care. Certainly, uh, staging mock drills and continuously Updating the fire suppression plan would be important. So these are different aspects that the textbook talks about when we're talking about fire suppression. Interior systems. The textbook talks about these different systems that are intended to enhance the overall facility experience. So things like lights and sounds and scoreboards and different interactive aspects that are driven by data. All of these are going to be part of a facility, the different facilities system, and they're intended to enhance our comfort. It's no surprise that one of the important investments facilities are making nowadays are on upgrading Wi-Fi, or at least having Wi-Fi that's capable of supporting a percentage of those who are at the facility. The Dallas Cowboys facility, or Jerry Jones's facility, signed on with AT&T, so that AT&T not only would have naming rights for that facility, but would also install different access points to enhance the quality of the Wi-Fi, and that's important. The textbook talks about fiber optic cable and making sure that Wi-Fi can be installed to avoid the massive amounts of fiber optic cable and coaxial cable that are going to be running throughout the facility that could inconvenience and create sort of chaos with having to install that wire either in the wall or on the ceiling. So having Wi-Fi is certainly important. And like I said, the future facility communication is going towards fiber optic cable and Wi-Fi, and figuring out how much you need, because when you're building a facility, you need to plan for the future. That's certainly important. The other aspects related to the facility are the exterior systems. What we're talking about here is the roofs and drainage. So the textbook talks about these different types of roofs. There's a small sun canopy roof, which is only going to accommodate a specific part of a facility. But then there's full roof canopies, which are going to cover the entire facility, domes, and then retractable roofs. And we've talked about these in previous chapters, so I won't dwell on it here. Textbook also mentions landscaping, which is important. Landscaping not only can beautify the facility, but it can also help with ingress-egress strategy, can help with cooling when we're talking about different types of plants. It can also help with beautification of the facility and taking up open spaces. There's also transportation. So there's vertical transportation and horizontal transportation. Horizontal transportation is more about moving people from one place to another. So that could be people movers, could be escalators, it could be those moving walkways, and then vertical is more about up and down. That's for your elevators. But we also talk about in the textbook little carts and little gators, etc. So those are also important to a facility, but making sure all of these transportation systems are properly maintained to guard against potential accidents or violation of the duty of care, that's also important. Parking lots are also part of the exterior systems, and parking lots are important in terms of a policing standpoint and making sure that those who might be subject to potential harm, whether it's through criminal acts of people who are intoxicated or maybe slipping and falling, it's important for a facility manager to understand that it's foreseeable that injuries could happen or incidents could happen, whether it's a fight or assault or a robbery or underage drinking or scalping, and these are all potential civil and criminal violations. And therefore, that facility needs to protect those who have paid for the right to be on the premise, protect them from foreseeable risks of harm. This is where negligence and being on notice are going to come into play. So in addition to vigilantly policing your parking facilities and being on guard, a facility should also have an alcohol management policy so that the risk that's associated with people being overserved or committing crimes or injuring themselves that can be mitigated. So that's certainly important. Um, the facility then, this chapter ends by talking about combined interior and external systems such as security systems. So biometrics and access control, reading, being able to scan people's eyes or fingerprints, or closed circuit television. One of our recent facility tours um, here included a room where the management could access over 100 different cameras that were connected through Wi-Fi to a central area where all those cameras could be brought up on flat screen television, and those cameras are remote controlled. They could zoom in or zoom out, be manipulated up, down, left, right to get better communication, so that if someone radios in that there's a potential incident, the facility manager or the security manager could immediately check and monitor, and those cameras went on a continuous recording loop that lasted, I believe, about 3 weeks to a month. So that was also very important from a security standpoint in abiding by duty of care. So we will continue to see different innovations in security systems, and that is going to be important for facility managers to stay abreast. Pest control is also important. The textbook mentioned that the Astrodome used cats to help to cut down on rats and mice. So I thought that was very interesting. That also helped to avoid sprays and chemicals for a facility, and also waste management. The textbook talked about how different waste management strategies can be used to mitigate the cost that facilities would have to pay for that service. So facilities, hopefully you learned in this chapter with facility systems, really encompass numerous systems that are going to help a facility operate and hopefully provide comfort and convenience to those facilities, but also other aspects, whether it's security or utility function. Uh, every facility is going to have an HVAC system, at least that we're going to be looking at in this course. And it needs to be built and installed and managed effectively so that not only people who come to that facility can be kept safe, but also can be kept in comfort. So hopefully you enjoyed this overview of chapter 7, and I look forward to discussing this with you in class.